So, welcome back everybody to episode 11 of Error Correcting Erik, where of course every week where we go to a chapter of David Deutsch's Beginning of Infinity. And this week we are in chapter 11 where we talk about multiverses.
Indeed.
And this is a really interesting one because it's quite of a lengthy chapter. It's also quite technical. For me it was also quite complicated.
Yeah.
So let's see how much knowledge we can condense from this one. And the funny thing is that I thought that I had a superficial, basic understanding of things like quantum principles, quantum theory. Not that I'm educated in that, but I watched some YouTubes and I considered myself to have a basic understanding of the double slit experiment and so on. Until you start reading his take on the multiverse and quantum principles, and then suddenly you realize, like, oh wow, I don't know anything at all.
Right.
It is probably completely different than what I thought, and than what I imagined.
Right.
And I can imagine that that's true for most people.
It is, and I would say similar to our puppy episode, let's not get lost in let's not discuss things that we are either not interested in that much or just haven't, I guess, read up, and maybe we'll do an errata next time, and Bart, you can call us out again.
Yeah, exactly.
But I would say let's keep it to what we kind of know and understand. And the other part there would be when you said that you probably don't do. I would say Deutsch would disagree that the fact that there is such a thing as probability altogether.
Exactly.
So that statement saying something is probably not true is not a factual statement. But
I see.
That is expert level critical rationalist.
Yeah. All right. Some important principles. Let's, of course, fungibility is a really important factor. But let's first talk a bit about the multiverse in general. So most people that read a lot of science books or like are into science fiction, they will have come in contact with the multiverse probably, or it has been portrayed in many movies and stories. Everybody and their grandmother has seen the Avengers movies where the multiverse is presented like a universe, maybe like an orb or ball or something, and then there's like a void of nothingness, and then there's a different multiverse, and like our heroes travel from one universe to the other. So that's a bit the multiverse concept.
And there's doppelgangers and all these things. And,
and things that happen in our universe don't necessarily happen in the other. So spoiler for that movie, like the bad guy wins, and then they travel to the different version of our universe where the bad guy hasn't won yet, and they try to undo it. So that's a bit of the general multiverse concept that people kind of grasp.
The pop culture, how they kind of...
exactly. How it's portrayed in most stories, movies, or books, or podcasts, or whatever.
Right.
But that's not necessarily how our real multiverse works or functions. And another important point about that is that for David Deutsch, it's not as much as a theory. For him, in his view, there is proof, there is evidence that the multiverse is real and that certain things, so this is not mentioned in the book, but I did some additional research on some of his other podcasts because I didn't grasp all the concepts. So he says that just as we know for sure that dinosaur existed, nobody's ever seen a dinosaur, but the evidence is there. We have the fossils and everything and the DNA, so the evidence of the dinosaurs is there. Similar to that, according to him, all the evidence of the multiverse being real and having real implications is also there. And this is something that we discussed in the very, very first episode, the double slit experiment. For me, that was one of the first instances of, and for David Deutsch, it's the proof of the multiverse. Because the previous explanation for the outcome of that experiment was like, a photon or whatever, or an electron, it must go through two slits at the same time. So it's like a
particle and a wave.
It's like a probability cloud, and then once you measure it, like the probability wave collapses, and then you get one. But David Deutsch says, nah, that's bad explanation. It can only be explained by the multiverse. So let's get into that.
Let's do it.
Before that, the concept of fungibility, because that's not a term I think that a lot of people use daily. So fungible means, for example, that two things are considered the same and interchangeable. Let's say that we're playing poker. We have a stack of poker chips. These poker chips, they're just a piece of plastic. They are a token of value. Let's say we have a chip of 10 euros and you have a bunch and I have a bunch and we take a bet and I win and you owe me some chips. It doesn't matter which particular chip you give to me, as long as it's the correct amount.
Right.
If it's that 10 euro chip or that one, it doesn't matter. So they're considered fungible. They're considered the same, interchangeable, even though they're different physical objects.
Right.
It doesn't matter.
Yeah, somewhat. You're on the right track there, I'd say. But that was quite the intro there.
Yeah.
I would say, yeah. So on the multiversal sense, like you raise an interesting thing. It's the best explanation for what we have, and I think this is just a critical rationalist view. Is anything that is the best explanation that we have today for the phenomenon or the thing that you're trying to describe is the thing.
Yeah, I see.
Like in dinosaurs is one of his favorite, David Deutsch's favorite examples, is because he's nobody has ever seen a dinosaur, nobody has smelt a dinosaur, nobody has touched a dinosaur. Yet we all know, and we don't even know because of their bones. We know from the fact that their bones have become fossils, and those fossils now are, I forget what the exact chemical compound is, but they're no longer bones, right? Yet
they're stone.
They're stone. So there's literally. Nobody saw one or deduced, nobody deduced that from said, fossil, right? We had to have the theory of fossil. We had the theory of evolution as well together to come to the best explanation of what that particular thing was that we identified in the ground.
Yeah.
And and there you build up toward dinosaurs, right? It's the explanation. It's the best explanation that we have for that thing. Similar for anything else, you would always have to go via the best explanation that you have available to you. That's not to say that there's not a better one, because probably there is a better one, or the more nuanced one, or Newtonian to Einsteinian physics is a really good example. Newtonian is very good, but it's just wrong because Einstein has a better explanation. So there's that aspect, and you brought that up, which was obviously correct to say, is that whatever the best explanation is for something, we should consider that being true.
Yeah.
And I think the fact that the multiverse is true in that sense, right? It's our best explanation, and I think the only reason why it's not been kind of validated as the actual versus the Copenhagen interpretation, which has the shut up and calculate type of things, right? That I think we spoke about previously.
Yeah.
The only reason why that's not been done is because the critics have put the onus on the multi worlds interpretation to prove a certain thing, similar to consciousness and all that stuff. So as long as technically they will not accept the results of the multiverse or multi-world interpretation until we have created artificial intelligence. I mean actual our type of artificial intelligence.
Okay.
Yeah.
Don't see how those two are related, but
and I don't fully understand it somewhat, but that's beyond the scope of this chapter. But let's say as long as we don't have AGI apart from ourselves, the Copenhagen guys won't be happy with accepting the multi-worlds interpretation.
Okay.
The
day we have it, suddenly they'll.
Then we can do a test.
Okay.
That would prove it.
Interesting.
Yeah. And it has to do with the pathways of the photon taking that way or that way on the silver mirror. It has to do with those things. Again, beyond the scope of this particular episode. But then coming back to fungibility, there's the parochial fungibility that you spoke about, for example. But I would take it even further, because the physical chip is still very much I could put a marker on it, right? Yeah. And all of a sudden we would be able to distinguish between it.
Yeah.
And I could have more sentimental value because I put something on it.
Yeah.
So that wouldn't be fungible anymore.
Yeah.
Because it never really was. But from a gamification point of view, I understand what you meant. I think a better analogy is the electronic bank money that we have now. So I usually don't carry cash with me. A lot of people do. We all have it electronically now, and the bank kind of it has it there. And there used to be the gold reserve. where the amount of gold need to represent the amount of money in circulation, and that's again beyond the scope of this. But then we get more into Austrian economics. But so what happens is that dollar that you have on the bank account, let's say that you owe to the taxes at the end of the year, unfortunately, it's not the same dollar that you quote unquote earned from your labor that you are then giving away to the tax authority, right? It's not like they had that specific dollar or they had that specific byte on the computer that represented your dollar. Yeah. So in that sense, it's fungible because it doesn't really matter that it was the first one or the last one or the third one or the fourth one. There is no such thing even as a first or a third one anymore. Exactly. Because you just have like €1,000 or $1,000, and then what's the first and what's the last? It doesn't work that way. So in the multiverse, fungibility takes another, like I say, quantitative step beyond that, because a lot of people would accept, and I like the example that he gives in the book about ponies, like if you would have, or horses, sorry, if you would have identical genetic horses, you would still not accept the twin horse. If you loaned your twin horse out, you would still want that exact horse back. You wouldn't be okay with the clone of that horse. Exactly. So there's all these like funny examples that you can think about to kind of speak about the concept of fungibility. But as it relates to the multiverse, and maybe it takes time, it took a lot of time for me to get my head around what fungibility is in that sense. But basically, once you go into the multiverse, right, we are all fungible things. So the entire universe literally here exists out of fungible instances, which means that, for example, one of your atoms in your body, right, is a fungible multiversal object, which means that it doesn't only exist in this universe, but it exists also in other universes. And that has to do with the history of multiversal objects. So I know it sounds wild that there's such that you are now in a billion uncountable whatever amount of universes at the same time, but it is the best explanation for our universe that we have today, right? So they call it the argument of incredulity. It's not an argument. It's not because you can't grasp it. It doesn't mean it's not true. A lot of people say, well, that's crazy. How can that be true? But then the argument becomes, well, it's not because you don't get it. That doesn't make it not true. Similar to when they first discovered the sun and they discovered other stars, it's like saying, oh no, it's insane that there's like a billion stars out there because we saw the one. Right. So an argument from incredulity is not a good argument. So the fungibility component from our multiversal objects that we are have to do with the fact that we just live in a multiverse. There's multiple instances of you and me that are doing all of this right now, but also a lot of other versions of us that are. I'm sitting there now, and you're sitting here. I'm having water. You're having the coffee. Like I came here by car, and you by bike. Again, there's literally limitless ways that this happens. And so that is once a pathway of that molecule changes, it branches off into a different history. So so the components that we're made of, the atoms and blah blah blah, are multiversal objects, and every time something happens to them, they branch out in a different history and become a different universe, kind of, because they are a different universe. They are together the multiverse. And I remember Brett Hall once said that he got questions from people saying, "Yeah, but what does it feel like to be in a multiversal fungible thing?" And he's like, "Exactly how you feel right now. That's what it feels like. There's nothing special. Like, that's just how we are. That's what it is. It's like all of a sudden when people tell you, oh, the earth is round and turns around, it's not like you're flying off of the earth all of a sudden because you have this realization that the earth turns around its axis, right? It's just a reality that we have.
Exactly. What I think that most people find difficult to grasp is that there's he calls it doppelgangers. There's like another version of you who does different things. But if we bring it down to a more microscopic level, it's a bit more understandable. And that's also where the experiments and where the proof, because we talked about the evidence that there is for the multiverse, where it comes from. It comes from the microscopic world, such as the double slit experiments and many other iterations. So what it basically means is, let's say that you have a single electron or a single photon or a single atom, that doesn't matter. What David Deutsch describes is that there are instances of that, so copies, which are fungible, which are identical, which are the same. And then multiverses,
they're more than identical. They are the same.
Yeah, exactly.
Yeah, it is the same.
It is the same.
It is a multiversal object.
Yeah.
Quickly before you continue, one of the best ways to think about this is when you are looking at a statue, you don't see the behind of it.
Yeah.
Yet you know it's there.
Yeah.
It's the same thing.
Yeah, exactly. Yeah.
You just see one sliver of it. That doesn't mean the other part doesn't exist.
Yeah, exactly. And what's also important there, it's not like because in the popular media and stories we see the multiverse like in a different place and we jump. No, it's like, let's say it's not completely true, like occupying the same space. No,
it is the same space. Yeah.
So it is across from each other, interwoven in each other, but we can only see one, or we perceive one, or we experience.
We are one.
Only. Yeah, we are all.
Oh, we are all
one
yeah,
of it.
Yeah. But we are one history of that.
Yeah, exactly. But on a microscopic level, it's a bit easier to grasp. But I'm not sure if he states that in the book, but as far as I understood it, in the early experiments or in the early reasoning, scientists believed that like the multiversal aspect or the quantum aspect would only apply to like the very small things on the molecular level.
Right.
But that's not the case. It applies on the whole of reality. And that's a big, because the first thing that I heard, what you said about shut up and calculate it, I remember the very first episode that we discussed. I had a conversation with a colleague who studied physics, and I was happy because for the first time I was like, oh, he's going to give me a good explanation of the double slit, you know. And all he told me, oh, it's just a fundamental property of an elemental particle, and it only applies to the elemental particles. Right. Well, there are two faults in that one. First is that's not a good explanation, and it's not a fundamental property of only that microscopic particle.
It's reality.
Yeah, exactly.
It's
for the whole of reality.
Yeah.
And that's a big difference and in way of thinking about the multiverse.
It is, and I think a lot of the the, let's say, the butterfly effect and all these things. Remember, like really small, but in an analog system would effectively be able to create a hurricane, for example. But we don't live in an analog world, almost, if you will. We don't live in an analog driven system. We almost live in like a digital. Quantum mechanics is almost like digital in a sense, if to make a comparison. It error corrects, and it doesn't allow for these grand fluctuations. And again, it's maybe beyond the scope here, but the entanglement is also something that comes up in the book, because on the microscopic level, entanglement happens very quickly. So that's why we don't perceive, again, I'm using this term loosely, perceive the multiverse in itself, because once you go beyond a certain size, entanglement occurs, and you can't really take them apart anymore, if you will. It's really on the microscopic level that these quantum fluctuations, I don't know if that's what they're called specifically, but these quantum phenomena happen. And there's like theories that time, for example, is a quantum phenomenon. Like also Lee Smolens talks about it. He says he argues that, or he conjectures that the time is a what's the word? Not the core, but a secondary phenomenon, like is a side effect. Sorry, time is a side effect of motion.
I see.
Rather than motion existing within time.
I understand. Yeah.
But I don't know how. I haven't put Lee Smolens' conjecture there together with David Deutsch yet, so it's to my best knowledge two separate theories. But then, in the end of the book, Deutsch speaks about time as a quantum phenomena. Okay, back from a little intermezzo.
All right.
Apologies.
Let's continue.
Yeah, so I think on entanglement, a lot of these phenomena happen on a microscopic scale, but then quickly go away because of it has to do with certain electromagnetic forces, whatever. Again, not entirely sure there. Sorry, but to get a quantum computer, for example, you need to cool down almost until like 0 Kelvin, because otherwise quantum phenomena and entanglement kick in.
Yeah.
So we've only been able to make a quantum computer up to like 10 qubits or something, for example, because it takes such a big sophisticated machinery to cool down the entire thing up until a level where quantum phenomenon and entanglement basically doesn't exist, because the premise of how a quantum computer is built has to do with the fact that entanglement, the phenomenon of entanglement should not arise.
Yeah.
So that makes it again what I said in the beginning. I don't understand it completely. It gets too technical for me.
Yeah.
But I kind of see it as, if you go a little bit slightly bigger, what happens is the our part of the universe is no longer separable from the other one.
Yeah.
And one of the most fascinating things that I found was that the quantum computer, for example, I think the most simple one that we have, can actually calculate, I think, can do more computations than there are atoms in our universe alone.
Okay.
Which means, where's it getting its resources from?
Yeah, exactly.
The multiverse.
Yeah. And that was a big insight for me, because that was indeed a completely different understanding of what a quantum computer is, because I always understood it like a normal computer is like binary, it works with ones and zeros,
Right.
and like a quantum computer can work with like linear values, so it has different algorithms or something, so it works in a different way. But no, it works based on actual interference with the multiverse.
Yeah.
So, and he describes it a bit as, let's say that you're working on a math problem, a computation, and you have to work on it alone. Or you have a lot of copies of yourself, a lot of Thomases in different universes, and you send them all a copy, and they all work on a little part on it, parallel, simultaneously, and then they all feed it back to you.
Exactly.
So you can do it way faster, or you can handle way more. So
that's a good analogy.
that's what a quantum computer is.
Yeah.
And that was just mind-boggling to me. So his definition is a quantum computation is a computation in which the flow of information is not confined to a single history.
Right.
And that's it.
It uses all of the histories.
Yeah,
basically.
yeah, exactly. So
Yeah.
that was for me a new big insight, like a side effect of like the multiverse, that we're using that, so we're getting energy load. Let's not call it energy. We're getting efforts from the multiverse.
Which is energy.
In a practical application like a quantum computer.
Exactly. Yeah. If you could somehow not entangle yourself entirely, and I think that's kind of the analogy that you were making, and you could like call upon all your multiversal selves, and all together do the same math problem.
Yeah.
And you would solve it in the hopefully, maybe not my versions, but, but
Yeah.
yeah.
Some versions of us who are slightly better.
There's another version out there that is a math geek.
Yeah.
Yeah, and I could go and get his help.
Exactly. Yeah. You wanted a specific one.
Exactly.
So we've talked about fungibility, about some quantum effects, about some quantum computer, about what the multiverse is, of some interference. Let's go a bit. One of the most important aspects is the history part. Let's go a bit more into that, because that's something that for me is still very difficult to grasp and to understand. So can you explain a bit? What does that mean? The little histories, and then being entangled, and then branching off, and so on.
So a history is basically like what you are now. And then let's say, I think the easiest way to describe it is in terms of a decision that you've made.
Yeah.
For example, you've made the decision to, take the sip of water now rather than 2 minutes from now. That would be a different history, because in this one you did do that, and the other one you didn't do that.
Yeah.
A good example is when you're driving, a part of you goes left, the other goes right. right? And basically those histories branch off.
Yeah.
They can never come together again. And this solves like a little bit of what they call like the grandfather paradox in time travel, for example. Not to say that I think Deutsch says that the time quantum thing isn't been resolved yet, because he thinks it has to do with branching quantum and relativity theory together. Like as long as those two don't come together, he conjectures there will not be a quantum theory of time. But he does, I think, have intuitions about it. But then let's say you would be able to go back in time. You wouldn't go back in time in your history.
Yeah.
You would go back in time into another history, and that would solve the so-called grandfather paradox, where you go back and kill your grandfather.
Yeah.
And the paradox is, if you go back in time to kill your grandfather, you would have not been born to do it in the first place.
Yeah.
Right. I don't know why these paradoxes are always like with killing people, because there's less hostile ways to do these paradoxes.
I think it's probably an ancient philosophical thought experiment, and it's also, of course, popularized by the movie Back to the Future, where he goes back in time. He doesn't like kill his grandfather, but he accidentally he causes some events to occur that his father and his mother, they don't meet, they don't go on a date, so he's not born, and he slowly starts to fade away from reality. So thus he has to go back and undo that to make sure that he doesn't disappear.
Exactly. So the multiverse would solve that paradox and would just not make it a paradox. And if you go more into the philosophy of logic as well and paradoxes, often what is a paradox is just a conflict we haven't resolved yet, because the universe is consistent. A paradox by definition means an inconsistency, something that you cannot resolve. So the better explanation is our ideas of them haven't been resolved yet, rather than they are unresolvable in principle. Right? It's like Fermi's paradox, which has also been badly coined, because it's not really a paradox. It's just like it's a problem, but
we haven't found a solution or a good enough explanation.
We haven't resolved the two parts of the equation that seemingly are paradoxical.
Exactly.
But it doesn't mean they are paradoxical. So I guess from a history perspective, like whoever you are now is your history, and you continue on that thread. But every time other branches of you have their own history. And this is the fascinating part of it, is that everything but knowledge tends to become more the same in the multiverse. So the stars out there are roughly the same everywhere in the multiverse. The atoms are roughly the same, stones, mountains. Matter in dark matter, whatever, not that we understand that yet at all, but let's say those things are similar through the multiverse, because they don't error correct. While knowledge, which is an error correcting phenomenon, has a limitless ability to be different. So you here might be you in your car, in your electric car, or whatever, but another universe might be you on your electric vehicle flying to Mars. Because the knowledge created over there would have been different.
Exactly.
So it was a very profound insight for me to see I like to see it as branching. So let's say you have an idea in the multiverse. So that idea exists throughout the multiverse, right? And you see all other matter as kind of staying the same. Yet our reasoning are the ideas that we hold that do affect physical reality disproportionately, right? It's a small thing. It has big consequences. Right? An idea built a bridge, right?
True.
Nature didn't do that by itself. I mean, we are part of nature, but you know what I mean.
This is what we discussed in one of the previous chapter, that like a bridge doesn't emerge, or a building doesn't emerge on itself. You know, stars and planets and moons and gas clouds and volcanoes and but then you need knowledge to transform things into another. So that's where bridges and buildings and roads come from.
And it is that knowledge. It's not even that knowledge does it. Like, it is the same knowledge. The knowledge that a bridge has is literally the same knowledge that the person that knows how to build it has. It is identical knowledge. It is just in a different physical substrate.
Yeah, I understand.
In the bridge, it is in the actual physical bridge that knowledge exists. In your head, it's in your neurons and the way that you simulate, that bridge basically.
Yeah.
But it is literally the same knowledge.
Yeah.
In a different, medium.
Yeah, that's what Deutsch in previous chapter describes as like encoding the knowledge. Let's say that we have never seen a bridge before, and suddenly there's like a bridge from ancient Romans. The knowledge is contained in that bridge because we can study it, and from that we can derive how it was built, which materials was used, and then we can internalize the knowledge, transfer it to a plan, and then transfer it to a new bridge.
Right, it will all be the same knowledge.
Exactly. Yeah.
So back to the branching of the multiverse. So a fun way that I like to look at it is saying, you see all the rest of the atoms or multiversal objects are kind of not doing a lot, and then you have knowledge, and that just branches off into the multiverse, and it does different things.
Yeah.
And it goes beyond, and it goes into all the crooks and candies, and actually becomes a bigger structure. In the multiverse. Knowledge in the multiverse is the grandest of structures.
I see. Yeah, that's an interesting one.
Yeah.
I didn't think about it that, because just to clarify on branching, so let's say you have the instances of an object.
Right.
As soon as something like changes for reasons, let's not go into that, and it doesn't change into a different instance of the multiverse. I was going to say into a different universe, but that's not how we describe it. So you have the multiverse and you have instances of like physical objects.
Yeah.
So once something changes in one and not in the other, they are no longer fungible.
Yeah.
They become different or non-fungible. So it branches off.
Well, they're still fungible. They just have a new history.
Yeah. Okay. Yeah. I
You
understand.
remain fungible.
Yeah. Okay. I understand.
Yeah.
Yeah. So that's what we mean with branching. But now
so
indeed,
it's constantly. It's like every
Yeah.
time you do something, and your knowledge does something,
it branches.
It branches.
Yeah, exactly. But let's say that without knowledge, the universe would like branch in a bit,
Somewhat,
but
yeah.
with knowledge,
Yeah.
it branches constantly.
Right, like
Yeah.
a big tree that spurts out of the ground.
Interesting. Yeah.
and just keeps going.
Yeah. Cool.
All right.
Yeah. All right. So we discussed quantum computers, quantum entanglement, some interference, fungibility. We didn't go into why the proof of the multiverse, but because let's assume that that's very technical.
Yeah.
But there are a lot of things there. The fact that the quantum computer works should be like proof on itself. Yeah.
Exactly. It's the best explanation.
Exactly. Any other things that we need to discuss about the multiverse before we wrap this episode up?
I think I'm good.
All right. Yeah. Cool. Yeah. I also don't have any other things to mention or to discuss. So I want to thank everybody again for listening in, and join us for next time, where we will talk about, it will be chapter 12, and let's have a quick peek what it's about. A physicist's history of bad philosophy.
Oh, yeah. It's all good.
Yeah. Looking forward to that one. See you next time.